overseas international cooperation and exchange activities. For the human space flight, I think we have seen the modern history from cosmonaut Yuri Gagarin to astronaut John Glenn, if we don't count Alan Shepard, and then from the Apollo Soyuz missions to the International Space Station. I would say from the space rig to the space cooperation, and then the International Human Flight Cooperation on a much broader scale. For the future manned space flight, I will talk about my personal view. I would like to say somehow that in the future, that peoples of different colors, different races, and different beliefs can really work together on the basis of mutual respect, equality, and mutual benefit. Thank you very much.
Thank you, Mr. Gao. Now we'll get a chance to meet our panelists.
We as the space community have long ago realized that expanding beyond the Earth and becoming a space civilization is the only sustainable long-term future for humanity. In order to achieve this, I believe that we need to begin the exploration of asteroids. Asteroids are thought to be the leftover material from the formation of our planets, and are therefore an important historical record of our early solar system, and may even hold clues as to how it was formed. Asteroids are also a potential threat. If a sufficiently large one were to impact our planet, it could result in the same kind of extinction-level event that wiped out the dinosaurs. So by expanding our knowledge of asteroids, we can learn how to protect ourselves from such a catastrophe. But we can also turn that threat into an opportunity. That's because many near-Earth asteroids contain vast amounts of water, metals, and volatiles. Mining asteroids can have a significant positive impact on our society in many ways. For example, we could create a thriving space economy that supports Earth with precious resources. So by making asteroids our next destination in space, we will be taking the first steps towards building and protecting our future, as well as our planet.
Thank you. Jonathan Lund is currently in his final year. Jonathan is currently in his final year of PhD studies at the University of Wits in Johannesburg, South Africa, where he is studying new ways to improve the performance of the vacuum arc thruster, a type of plasma propulsion system that can be used to maneuver small satellites. After working as a design engineer in the petrochemical and metals industry, he joined the Space Science Directorate of the South African National Space Agency in 2011. Recently, Jonathan co-authored the first and only dedicated space plasma propulsion research facility in South Africa. He's also a recipient of the Emerging Space Leaders Grant Award to attend this year's Congress.
Jonathan, why would you say that exploring asteroid should be the humanity's next step versus the moon or Mars?
Well, I think there are three main reasons why we should be exploring asteroids. The first one being scientific, because asteroids offer a historical record of our solar system. So if we can explore asteroids, we can actually find out more about how our own planet formed. There's also the possibility of us finding microbial life inside an asteroid. There might be some microbes encased inside an ice pocket inside a body, and I think that's something that's worth exploring. The second reason is social and ecological, because I think we're all aware of the dangers of an asteroid collision. And if we can take the steps now to understand how asteroids behave and what they're made of, we can have a better idea of how to prevent such a catastrophe. And the third reason is something that's been getting a lot of media attention lately, and that's the economic potential of asteroids. I think that if we can learn how to extract resources from them, it'll set the foundations for ensuring a long-term and sustainable exploration of our solar system.
Thank you, Jonathan.
I believe the best solution would be the moon and its lava tubes.
Lava tubes? What's a lava tube?
They are natural tunnels constructed by ancient lava flows. You can find them in many planetary bodies, like Earth, Mars, or the Moon. Lava tubes are fairly easy to access, and on the Moon, they are much bigger than on Earth. And they are buried tens of meters under the surface. And these characteristics are what make them really interesting, because as they are natural shelters, they protect against most of the harsh environment you will find on the surface. Also, a lava tube provides many advantages, and they simplify the construction of a permanent settlement. Thanks to its depth and its roof, inside the lava tube there is no radiation, no dust, no meteorites, and even better, the temperature stays stable at -20 degrees Celsius day and night. So, unlike any other destination, settling a base in a lava tube would be very easy. Habitats could simply be inflatable tents that just have to resist the vacuum, not too hard. Also, all these simplifications will promote commercial activities, such as transportation, resource mining, or even space tourism. So I hope one day this artistic vision will become true.
Guillaume Tanier is a young professional currently working as a consultant in computer and software engineering in France. He's always been passionate about space exploration and human spaceflight. In 2011, he earned a master's degree in space studies from the International Space University, where he furthered his experience in embedded systems and robotics. As a summer intern at the Jet Propulsion Laboratory, he developed operational concepts to explore and settle extraterrestrial lab tubes with NASA's Athlete rover.
Yeah, Guillaume, with your idea